In a silent vastness beyond Pluto, something is moving. A tiny speck of light is heading inward from the interstellar dark. It is clearly not from around here. Astronomers have just realized that we have a visitor from another star system, the third ever discovered since a mysterious Oumuamua stunned the world in 2017. In mid-2025, a telescope in Chile detected this mysterious object moving along at an unusual trajectory. At first, it was just a faint blip in the Asteroid Terrestrial Impact Loss Alert System, or ATLAS for short, which scans the sky for anything out of the ordinary. The discovery caused a wave of excitement and confusion. Was it a comet? An asteroid? And why did its trajectory look so strange? Music. The object was first spotted on July 1st, 2025 by the ATLAS Survey Telescope in Rio Hayadu, Chile. Initially labeled with a cryptic designation A11PL3Z, it quickly drew attention as its orbit didn't match any known within our solar system. The next day, the International Astronomical Union confirmed what many had already begun to suspect. This was an interstellar object, only the third ever found. They officially named it 3I Atlas, where I stands for interstellar. Picture this, a chunk of rock and ice having traveled from another star now passing through our cosmic neighborhood. For astronomers, it was a eureka moment. For everyone else, it raised an uneasy question. Should we be worried about this alien comet? The reassuring answer is no. There's nothing to fear. Scientists determined from beginning that 3 Atlas poses no direct threat to Earth. Its path will keep it at a safe distance. At its closest, it'll be more than 150 million miles from us, about 1.6 astronomical units, or 1.6 times the distance from Earth to the Sun. In fact, this visitor won't even come closer than the orbit of Mars. So, there's no risk of collision, only a rare chance to gain knowledge. Larry Dino, one of the scientists behind the ATLAS project, admitted that we don't know very much about this object. For experts, saying we don't know is both humbling and thrilling because it means something truly new has been found. Here's what we do know. 3 Atlas is up to 12 m wide, making it a massive cosmic iceberg. When first spotted, it was about 4.5 astronomical units from the Sun, 4.5 times farther than Earth. And now it's racing at an incredible speed of about 40 m per second. That's over 140,000 miles per hour relative to the Sun. No known comet from our system travels as fast on its own, so it's clear that this thing was ejected from far away. The Minor Planet Center's official circular made it clear we're dealing with something special. They reported tentative comet activity with a marginal coma and a short 3-arcsec tail. In other words, 3 Atlas isn't just a dead rock. It's already showing signs of life, like a comet waking up from solar heat. There's a coma, a fuzzy halo of gas and dust surrounding the comet's core, and even a tiny dust tail. It's beginning to sublimate, meaning its frozen gases are warming up and turning straight into vapor, forming a glowing coma and a trail of particles behind it. All of these observations took place when 3 Atlas was still very distant and faint, around 18th magnitude, far too dim to see without a large telescope. Yet the fact that we even notice it shows how far astronomy has come. It took global cooperation. After Atlas flagged the object, telescopes in Hawaii and Australia joined in to track it and map its path. Amateur astronomers dug through old images and found pre-discovery photos of the object hidden in data from mid-June 2025. These early observations helped refine its trajectory and confirm its interstellar origin. So by July 2025, the verdict was in. An interstellar comet was approaching, only the third ever seen by human eyes. Naturally, the next question was how this cosmic wonder compares to the others. To understand how unusual 3 Atlas is, let's recall its 2 predecessors. The first was discovered in late 2017 and given the Hawaiian name Oumuamua, meaning scout or messenger from afar. The second, discovered in 2019, was 2IR Borisov, named after the amateur astronomer who found it. The two were very different from each other, and 3 Atlas adds a new twist to the story. Oumuamua was a true mystery. It was small, about 100 yards long, oddly shaped, a cigar-like object, which had no visible coma or tail like a typical comet. As it moved away, it even showed slight non-gravitational acceleration, veering off the path predicted by gravity alone. This may have been due to gas outflow or something even more exotic. The strange behavior led to wild speculation, though most scientists lean toward natural explanations. perhaps a fragment from an icy world like Pluto. Either way, Oumuamua left us with more questions than answers. Borisov, by contrast, was more familiar. When Borisov arrived in 2019, it looked and behaved like a regular comet from our solar system. It had a bright gas coma and a tail, and its composition, analyzed using the spectroscopy method, was similar to known comets with water vapor and carbon-based molecules. If not for its hyperbolic unbound orbit, one might have thought Borisov was homegrown. Now we have 3 Atlas, and the main question is which of the two does this new guest resemble? Early signs suggest Atlas is more like Borisov and Oumuamua. It's faint and fast-moving, but has a typical fuzzy coma indicating the presence and evaporation of ice. This suggests it's most likely an icy comet-like body rather than a dense rock. It's important to note that it hasn't shown any obviously strange behavior so far. In short, no signs of an alien spacecraft at this time, just a very interesting comet from another star. There's, however, something quite distinct about this object: its size. The new object appears to be larger than both Oumuamua and Borisov combined. Based on its brightness at the time of discovery, astronomers estimate that it could be about 9 to 12 m across, significantly bigger than Borisov, which was around 0.6 to 1.2 miles in width and much larger than the tiny Oumuamua. If this estimate holds true, Atlas could have much more mass, potentially offering a richer supply of material to observe as it outgasses. Another contrast lies in the tilt of its trajectory and direction of travel. Oumuamua came from plane of the solar system, roughly from the direction of the star Vega. Borisov arrived from a completely different part of the sky, in the direction of Cassiopeia. Our newcomer seems to be coming from the constellation Sagittarius, roughly from the direction of the galactic center region. In galactic terms, Marshall Eubanks, the physicist tracking the object, notes that Atlas likely originated in the thin disk of the Milky Way galaxy. The thin disk is a flattened plane in which most stars, including the Sun, orbit the galactic center. This suggests the object may have formed around a star somewhere inside the vast swirl of the Milky Way's disk. Of course, we don't know exactly where that star may have been. To determine that, we'd need to trace back the comet's path and account for millions of years of galactic drift, which is practically impossible with current data. But the fact that it likely came from the inner galaxy already hints that it might be made from material similar to what we see in local comets. It's important to mention that all these interstellar visitors, no matter how different they are from one another, share one thing in common: they are not bound to the Sun. Each of them travels on an open-ended hyperbolic orbit, meaning they arrive, swing once around the Sun, and then head back to interstellar space, never to return. It was precisely this hyperbolic trajectory that told us Atlas wasn't local. Calculations immediately showed an orbital eccentricity of about 6, far greater than the value of one that defines a limit for bound orbits. This indicates the object is not tied to our star and came from beyond the solar system. Still, one can't help but wonder what story this object lived through before arriving here. Perhaps it was once a comet orbiting a distant star, peacefully circling its sun like Halley's Comet orbits ours. Maybe a close encounter with a giant planet in the alien system knocked it off course, flinging it into interstellar emptiness. For centuries, it drifted through the darkness between stars until chance brought it into the path of our sun. We may never know the full story, but as a third interstellar object draws near, we're gathering every clue we can about its nature. Now, halfway through 2025, 3i Atlas is approaching, and astronomers around the world are watching it eagerly. Let's examine its orbit and current state in more detail. What do we know about where it's going and what it is doing on its journey? The orbit of Atlas, as we've said, is highly hyperbolic, which means it's a one-time visitor. It arrived from interstellar space, and after swinging past the Sun, it will return to interstellar space. Specifically, calculations show it will reach its closest point to the Sun, the perihelion, around the end of October 2025. For Atlas, the perihelion distance is about 1.4 astronomical units, or roughly 130 million miles from the Sun. And practically speaking, that's just inside the orbit of Mars. It's also worth noting that on its way, the object will pass relatively close to Mars. In October, it's expected to come within 0.4 astronomical units of Mars, or about 37 million miles from the red planet. While not extremely close, that's still near enough for spacecraft orbiting Mars to possibly observe it. For example, NASA's Mars Reconnaissance Orbiter might capture an image when 3 Atlas goes past.